everyone, and welcome to lesson 25.1. Today's lesson starts on page 349 in your Springboard textbook, and you'll probably want a pencil, a highlighter, and calculator handy. Now, on page 349, we see a vocab word that you have actually seen before, but it's been a little bit of time, and that is bisecting ray. So just to remind you of what a bisecting ray is it occurs in an angle, and the bisecting ray cuts our angle into two congruent angles. So for instance, if we have ray AB, this is our bisecting ray that is cutting our big angle into two congruent smaller angles, right? Those are congruent to each other. Now we also have many other vocab words this time around, and this is where definitely some highlighting might come in handy, and that's looking at these different terms about central angles and then arcs, okay? Now a central angle is an angle whose vertex is at the center of a circle and whose sides contain the radii of the circle. So for instance, angle AOB is our central angle, right? This would be considered a central angle, angle AOB. Now, arcs then open up, are what our angles open up onto. Okay, minor arcs are intercepted by our central angle. So, for instance, here would be our minor arc AB, and they are going to be smaller than 180 degrees. You're between 0 and 180 if you're a minor arc. A major arc, on the other hand, for instance, AQB, this whole arc here, is called a major arc if it's between 180 and 360 degrees, right? 360 would just make it the full circle. So it would just be, so the major arc would be between 180 and 360, okay? And we notice this one is named with 3 letters as opposed to our minor arc that only got 2 letters, the endpoints of the minor arc. Major arcs get a third point that is also on the major arc, so we know we're talking about a major arc versus the minor arc AB, okay? And then last but not least, a semicircle, which we don't have in our picture, but a semicircle is going to be half of the circle, half of the arc. So let's say we have a circle here. Our semicircle is half of the circle. It measures exactly 180 degrees, and it's going to be measuring this piece here. Now, usually a diameter is going to kind of cut this in half, so we know that we have a semicircle there, and we would actually also have a semicircle on the other side, since they would both be 180 degrees. Now, there is a special relationship between our central angles and our minor arcs, okay? This angle measure, that's the measure of the central angle. The central angle is going to, the degrees is going to equal the amount of degrees of our minor arc, okay? So for instance, if we said that angle AOB was 60 degrees, we know that this arc is also going to be 60 degrees. Okay, the arcs are going to be the same. Central angles equal the arc length. Okay. Now, from there, as we move on to the next page, we want to start using some of that fact. So notice they're telling us a little bit of information in number 5. They're telling us that we have JR kind of cutting our circle into 2 congruent halves. And then we have angle RCQ is going to measure 50 degrees. So angle RCQ is this angle here. That's 50 degrees. Okay. Now, the reason they talk a lot about diameters is a reminder that diameters are kind of telling us, hint, hint, we have some 180 degree arcs, aka some semicircles running around. For instance, since we know KQ is a diameter, we know that that arc would be 180 or this arc would be 180. Okay, now we may or may not need to know that right now, but that's a lot of times what they're going to be using when we're talking about having diameters given. Okay, now going off of what they are talking about, the first thing they want us to figure out is what is the measure of arc RQ. Well, a reminder, the central angle is going to equal the measure of the arc. So since we know that our angle RCQ is 50 degrees, we know that that arc it opens up onto is also going to be 50 degrees, okay? And then our arc JQ, if we trace that out, is going to be part of a semicircle, right? So we know that this whole thing here, given that we have a diameter JR, is 180. So if that has to be 180 and we know this part of the arc is 50 degrees, total we're going to have a 130 degree angle. Excuse me, arc. Okay. Which does also mean that we can find this angle inside of here as well, which we'll talk about in a second. Okay. Let's skip angle CRQ for just a moment, and we'll talk about the measure of JQR. Okay. JQR is again this whole arc here. So since we know that one of the angles is, or since we know that this is a diameter, this whole thing would be a semicircle and 180 degrees. And then arc JKQ would be this arc here, J to K to Q, would be all of this half of our semicircle plus the 50 degree angle. So it would be the 180 degree semicircle plus 50 more degrees for a total of 230 degrees. And then we also have arc JK, which I know we've kind of lost some of the picture here. I'm going to erase it so we can see a little better. And then last but not least, we have JK is going to actually be congruent to QR, that arc, because we know that the vertical angles are congruent, so those arcs would also have to be the exact same size. Okay. Now, side note, we skipped part C. Part C goes back to if we drew in a little triangle here, if we connected these points, C, Q, and R, we know that C to Q and Q to R, these are radii. So we know that these two radii would have to be congruent. And if we know that this angle right here is 50 degrees, we actually know that this little triangle that we created inside here would have to be have congruent angles. So 180 total degrees minus 50 would be 130, and then each of them would have to be the same. So each of them would be 65 degrees. So kind of bringing back some old information on that last little piece. That was like a challenge question, if you will. Okay, but as long as you understand A, B, D, E, and F, should be good to go. Okay. Now, when we talk about congruent arcs, kind of like letter F, congruent arcs are arcs with the same measure. Right? So we have arcs with the same measure. So we can have congruent arcs just like we have congruent segments and how we have congruent angles. Okay. Now, we're going to skip over to the last page. Okay, and we're going to talk about a couple more things. Okay, so when we talk about a circle with a center and then here's a central angle, right? Something that the vertex of the central angle and the center of the circle have in common is that the vertex of the central angle and the center of the circle, they are the same point. Right? They're going to meet at the same point on this picture. And then another name for the sides of our central angle is the radii. Right? The central angle is going to be made up of the radii of our circle. Okay, so that's kind of special to our central angle. And then again, one last thing, the reason we need to talk about our major arcs having 3-letter names versus our minor arc having 2 letters is if I said arc AC and I didn't specify it with the 3rd letter, you might think I'm talking about this arc right here, AC, but we need the 3rd point if we're going to talk about the major arc. So we know the difference between which arc AC we're talking about, this arc or ABC, the major arc. Okay. Now we're also going to want to use this information to solve some things, okay? And that's where we're going to look down at number 14 here. Notice they're giving us the measure of the arc, and they're also telling us that our central angle equals 8x. Well, a reminder, something very important to note from this lesson is that the central angles degrees is going to equal the arc it opened up onto degrees, right? So the 96 and the 8x are going to equal each other. So in order to solve for x, we will need to divide 96 by 8 to get our final answer for x, which would be 12. And again, if we plug that back in, we would see that the minor arc would be the exact same size. Now, the major arc, this piece over here, can be found by subtracting from 360 the measure of our minor arc, because the leftovers then would be the measure of our major arc. So 360 minus 96, we would have a 264-degree arc. Major arc. Okay. Last but not least, our final example is actually having us look at somebody's work. So Emma is setting up the following equation so that we have 12x plus 6 plus 3x minus 6. She says that that is equal to 360 degrees. What do you think about Emma's work? Well, hopefully you realize that Emma is wrong because we're only talking about a semicircle when we talk about this arc and then this other minor arc. We're only talking about 180 degrees on this one, okay? So in order to actually solve this, you would want to change this to 180, and then we would combine our like terms of 12x and 3x. It's 15x's plus 6 minus 6 actually becomes 0. And so if we divide 180 by 15, we would get a final answer of 12 here for x, okay? If we had solved it the other way, we would have been looking for the whole circle, not just the semicircle. So be aware that the semicircle equals 180, whole circle is 360. Thanks everyone for watching this first lesson, and we will work more in class with our central angles and minor arcs.